Good morning, everyone. Am I audible?
Yes, sir.
Yes, sir.
And my screen is visible to all of you?
Yes, sir.
Yes, sir.
Yes.
Okay. CR of section A and B, are you present?
Yes, sir.
Okay. So CR of section A and B, please take a screenshot of the people now present. Just take a screenshot of all the names, and you can give it to me later on. Both section A and B, CR are requested to take the screenshot of all the name. You go to the people and take the screenshot of all the names.
Okay, sir.
Okay, just right now we take the screenshot. It is, and you send it through WhatsApp. Send it to me through your WhatsApp. Okay? So we'll start our topic. The first topic of my portion is shear strength of soil. So by that time you have started your uh, the initial chapters. I think 2 classes or 3, maybe 2 classes are over. So now you're little bit you know about the soil. What is soil, and uh, what are the, I think, constituents of the soil? Like, it has 3 parts, and you have all. I think here these things have been discussed in your classes, like two-phase system and three-phase system of soil. So my topic, which is shear strength of soil, this is a very important engineering property of soil, and this shear strength, this term, this shear strength, it actually determines whether the structure will be stable or not. Whether the structure which is built on the soil mass, that will be stable or not, it depends on this property of soil, that is called your shear strength, right? So safety of any structure, your depends on the shear strength of your soil. So I'll try to write, and uh, maybe my handwriting will not be that much good because of this online tab or pad, you can say. So uh, and another thing, I will request to the seer that if I get disconnected, uh, please inform me. Okay.
Sure,
So
sure.
try to take the class note. Okay, everyone try to take the class note. Just don't listen or just see. You just imagine that you are in a physical class, and you note it down whatever I am writing. You just note it down in your class note. So your safety of any structure, it depends on the shear strength of soil. So if your soil, if your soil cannot sustain the load, uh, what, so whatever is coming through the superstructure, then we will say that the soil has failed actually. Because of the failure of soil, if the your stress coming from the superstructure is greater than the strength of soil, then the structure will collapse. Then the result will be collapse in your structure. So we are using this term shear strength, strength failure. So you should have in your mind this question: what is strength of soil, right? What is strength of soil, and why we are using shear strength? Why you are using this term shear strength? shear strength. Not only strength, why this shear term is there. You should also ask what is failure. What do you mean by failure? What is failure? Uh, what are the causes of failure? Okay, so these are questions you should ask yourself. You should think about while you are talking the shear strength. So, what are the factors? What are the factors which are responsible for your shear strength? For the shear strength. Okay. Now, next question you should ask that how will we determine the shear strength? Determine the shear strength. So, in how will we determine the shear strength? In this question, you can think about like whether it is determined in your field or directly in the field or in lab or in lab. Okay. So if it is if we perform the shear strength test in the field or in the lab, what are the different tests? What are the ways or hello? Hello, am I audible?
So yes, sir, now you're
Yes, sir, শোনা যাচ্ছে।
Okay. 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 So these are the questions I am asking, and you should also like think uh, before starting of the chapter. What are the ways or different tests for the determination of shear strength? Okay. What are the different ways or different tests which we can perform in maybe in the lab or maybe in the field for the determination of shear strength of soil? So please ask, don't hesitate because it is very difficult to write in this pad actually. Uh, so then what are differences
টেস্ট ফর কি লিখে বলেছেন ওটা একটু বলবেন?
for determination of shear strength? Okay, for determination of shear strength. What are the then next question is what are the okay I'll be a little bit slow so that it becomes clear. What are the differences among the different
You are not audible, sir.
So your screen is not visible.
Sir, नहीं बोल रहा है.
अरे यार मीटिंग ही नहीं सेटिंग की सेट को
স্যার তো বললো কোনো কিছু হলে একটু ম্যানেজ করো।
ভাই অ্যাটেন্ডেন্স হয়েছে
লিভ করে রিজন করো
স্যার থাকলে যে ম্যানেজ করা যাবে. এই মাইকটা অফ কর.
এই স্যার কি ভাবছে স্যার পড়িয়ে যাচ্ছে
মেসেজ কর
আরে এই ভাই সাহেব মল্লিক কে তুই ভাই বন্ধ কর না মাইকটা.
এই সৌভিক স্যারকে মেসেজ কর
একই দেখতে পাচ্ছি আমরা বেরিয়ে গেছি.
একটু ওয়েট কর দেখি স্যারের মধ্যে কল আসতে পারে একটু ওয়েট করে যে একটা কল আসতে পারে তারপর 12:15 দিকে সেটা হতে পারে 12:15
আমার কন্ট্যাক্ট অ্যাড করতে সাথে বললাম না
10:15 কল কর বা মেসেজ কর হ্যাঁ ঠিক আছে বল
স্যার তো পড়িয়েই যাচ্ছে
প্রেজেন্টে নিয়ে ফাঁকে
এই এর পরে জিওটেকনিক্যালটা কে নেবে কি ও স্যারের নাম নারায়ণ জানতাম না। হ্যাঁ হ্যাঁ ইন্ডাকশন নিয়েছিল ঠিক নারায়ণ রয় না কি একটা নাম না
একটা ভালো মনে হয়েছিল
ঠিক ঠিক
ক্লাস শেষ ভাই
শোন সৌভিক একটা কাজ করি চল টিচারদেরকে বলে দিই একেবারে ডাইরেক্ট অফলাইন হয় ঠিক আছে
স্যারকে কল কর না।
কালকে ক্লাস হবে অফলাইন
হ্যালো শুনতে পাচ্ছ না? হ্যাঁ শুনতে পাচ্ছ?
না স্যার আপনি ছিলেন না এবার
স্যার আপনি
ওকে ওকে ওয়ান সেকেন্ড নেটওয়ার্কটা একটু ডিস্টার্ব করছে। এতক্ষণ যা বলা হলো তোমরা একটু শুনতে পেয়েছো তো?
হ্যাঁ স্যার।
আচ্ছা
স্যার আপনি দুটো মিটিং থেকে লেফট হয়ে গেছে নোটসটাও দেখা যায়নি কথাও শোনা যায়
5 মিনিট দেখা যায়নি তাই তো?
হ্যাঁ স্যার
আপনি প্রেজেন্ট করলে বুঝতে পারবো কতক্ষণ আর কি.
এটা পড়ার জন্য এখন সবাই ক্লিয়ার শুনতে পাচ্ছ তো?
ইয়েস স্যার
Okay. So, I am discussing about these questions only. Whatever I have written, these questions I was discussing that if you want to start your
Presentation is not coming.
topic,
স্যার your presentation
what happened? Is it, am I
প্রেজেন্টেশনটা দেখা যাচ্ছে না
okay? Okay. Section B. Is it fine now? Okay. Section A. Is it visible? Okay, I think now for both the sections screens are visible, right? So
What are the different tests for the determination of ওই কোশ্চেনটা অবধি হয়েছিল.
yeah, what are the what are the ways or different tests for the determination of shear strength, right? I have written here, is it possible? Then you can see that what are the ways and different tests for the determination of shear strength. Fine. So we'll discuss this question. Basically, in this chapter, you will get the answer of this question. Right? There will be more topic in this. There will be more subtopic in this main topic, but broadly, these are the question, or you will get the answer of these questions in this chapter actually. So that's why I have written these questions, and you should also, like before starting any chapter, you should know what are the things you are going to learn through this chapter. so that it will be clear to you. So what are the outcomes of this chapter. So we'll discuss slowly one by one. So today we will just discuss about the initial part, that means your stress part. So the questions, whatever I have written, like what is your strength and why shear stress. So these are the some topics we'll discuss, and then I will have a brief review. Okay, we will have a brief review about whatever you have written, already read in your earlier maybe structural mechanics courses. Okay. So I will have a just brief review of that, because these things are also necessary in this chapter. So if the load of suppose there is soil mass, and you are increasing the load on the soil mass, and then if the deformation of the soil mass becomes unacceptably large, or you can say very large, then we can say that the soil has failed. Right? So when we say the soil has failed, when with the application of the load, there is unacceptable deformation, unacceptable large deformation, then we can say that the soil has failed. uh, so that is failure. That means there will be deformation which is not acceptable. That means if there is deformation, a large deformation, that will ultimately lead to the collapse of the superstructure. So in that case, we say that the soil has failed. Now, when the soil fails, or when there is unacceptable large deformation, when the stress which is coming from the superstructure is greater than the strength of the soil mass, or to be particular, shear strength of the soil mass. So why we are using this term shear? Because in general, the soil mass fails due to the induced shear strength, not your normal strength, or you can say any other strength, because it fails because of the shear, not because of any other stress. That's why we use here this term shear
But,
strength.
sir, but for a building, the load comes along the normal to the ground. So
Right.
how it is becoming the shear force.
Yes, right. So that is why we are going to read this chapter, that the load normally acts on the horizontal surface, that is your normal stress, and because of this normal stress there will be failure. But what I am trying to say, that if you calculate your normal stress, and if you calculate the shear stress, when there will be shear stress, if you take any plane, so perpendicular to that plane, that is normal stress, and horizontal to that plane, that is shear stress, right? So if you calculate the shear stress on the different point below the your structure, or in between the soil mass, you take different point, and you take different plane, and you try to calculate the shear stress, then you will find that the region of your failure is not your normal stress. It is the shear stress. That means what I am trying to say, that if uh, there may be your normal stress. I'm trying to tell you that there may be condition where your normal stress is more than, if suppose just compare two cases. One cases is there is uh, the normal stress is less than the other cases. So you can find that for a particular combination of the normal stress there may be failure, and for a particular combination of the stress there may not be failure. Okay, even though that the normal stress is greater than the previous one. Okay, suppose case A and case B. Case A you are taking normal stress equal to 10. Case B you are taking normal stress equal to 20. Okay, but the means state of stress, you find the state of stress of a different point. There may be some points where the shear stress, what is the developed shear stress, will be such that that will cause the failure of that material of that sample. Suppose case A, there are some points which are causing failure, but in case B, there may not be that situation. So that we will discuss slowly. You will learn slowly that point. So you just try to now just understand that there may be cases. Suppose case A and case B, we are applying in case A sigma equal to 10, but case B sigma equal to 20. But in case of case A, there may be failure, but in case of case B, there may not be failure. How that is happening, we will discuss that slowly. Okay? So that is why we are telling that normal stress is not the reason of failure. It is the shear stress which is causing the failure of in the soil mass. So how it is happening, we'll discuss that, but not maybe today, later on. So we are discussing that stress and its strength. So that's why you need to learn about your concept of stress. So that's why we should have a preliminary idea about the stress at a point. So already you have read these things, but just for a review or just recap, you can. I will just try to have a brief introduction about stress at a point. This is stress at a point, right? So suppose this is a body. Suppose this is a body, and in this body there are many forces. Suppose this is F1, this is F2. There are some maybe distributed load W1. So suppose this is a body, and you now want to calculate the stress at point P. You take a point P and you want to calculate the stress on this point P. So what will be the stress at point P? Stress at point P.
So all total F
What will be the stress?
by the
Answer. I am asking you, what will be the stress at point P?
all the normal component by the area. All the normal component of the forces. Your force are not applying normal to the
All that.
plane.
Of
So the
the
normal
normal
component
component
of F1, F2, F3. All the normal component of F1, F2, F3 by the area, the surface area. And the reaction
which
force.
surface area?
All the,
Which surface area?
yeah.
What is the surface area here? I am taking a point. I am talking about point P. What is the area here? What is the area of point P? How will you calculate this? So these things you have already read, but just I'm trying to give an overview again. So see, this is point P, and you want to now calculate your stress at point P. So how will you calculate? So someone has said that we'll take the normal component of all the loads and reaction, and we'll divide the summation of the load, normal component of the load with the area of point P. So suppose this is point P, right? And I am giving you a plane. I am giving you a plane. This is suppose one plane. Suppose this is A and A dash. And I am giving you another plane. Suppose this is B and B dash. So now you are calculating the stress at point P, but on plane A dash, and you are calculating stress at point P, but on plane B and B dash. Now tell me whether the stress will be same or not. You are calculating, suppose stress sigma P along, you are calculating A dash. Okay, and you are calculating sigma P along your B dash. So will the be same value? The value will be same or different? Same or different? What do you say? Yes, Prof Sen.
Yes, sir.
What is your opinion? Just tell me your opinion. You need not to be correct.
So I think different.
Sir, different.
Different.
Okay, what is your name? Santopal.
Yes, sir. Santapal.
Okay, Santopal. So
Same.
you are telling it will be different, right?
Yes, sir.
So try to think. I am giving first. I asked you the stress at point P. Then I am giving you two conditions, two planes at the same point, two planes which is passing to the same point. So you are telling that the stress will be different. You are correct. So we cannot, or I should not say cannot, but it is not like if you want to calculate the stress, you need a particular point. You need a point as well as a plane. Okay, both these things you need to know to calculate the stress for time being. But we can calculate the state of stress at point P also. Okay, without any plane. Means we need plane, but we can say that we can say the state of stress at point P. So if you try to calculate the state of stress at point P, then you need you need your 9 different components of stress. You need 9 different components of stress, and I don't know whether you have read this or not. The 9 different components of stress you need, and for this you need to assume 3 different perpendicular plane. That means you can think of a cube. Okay, you can think of a cube, and there are 3 perpendicular planes, 3 mutual perpendicular planes. This one, and in this direction. Okay, so if you consider these 3 mutually perpendicular plane or a cube at point P, this is at point P. Okay, this is not some big thing I am assuming. This is just point P. In this point P, I am assuming different plane. One is suppose this plane, another is suppose this plane, this plane. So I am constructing a cube here, and if you know the state of stress in these 3 mutually perpendicular plane, then you can say the state of stress at point P. This is sigma at point P. You can then say the what is the stress at point P. So this we generally denote by your matrix. Okay, so this type of form you will get tau x z, then sigma and then you will get tau zx, tau zr, sigma zz. So these are the 9 component of stress you need to know. So these component of stress, how you will get? You will get through these 3 mutually perpendicular plane, which is passing through point P. Okay, so this is the state of stress at point P. So are you familiar with this? Section A, section B. Are you familiar with this?
No, sir.
No, sir.
No, sir. No, sir.
You can say yes or no if you are, okay. So in your structural mechanics,
Yes, sir.
who is saying yes, sir? Okay, I don't know whether this part has been covered or not, but this is your basic concept of stress. If you read concept of stress and strain, you must know these things, that if you want to uh, uh, if you want to say what is the stress at a point, you have to you need to know the knowledge of the 9 component of stress at that point. Okay. So if you have not written, maybe you will read it later. But at the timing, you just have the knowledge of that. If you want to express the state of stress, you need to know these are 9 components. Okay. And what is this sigma x, tau x, and tau x z? Suppose this is, if this is your uh, this is your cube.
It is a 3D state of stress.
Yes, yes, right. 3D state of stress. So in 2D, you will have similar kind of things, but maybe this will reduce to your this Z component will not be there, so it will reduce to your 4 components. Okay. So so if this is your X, this is your Y, and this is Z. So in this plane, this is sigma XX, and this will be your tau XY, and this will be your tau xz. So these are 3 components of stress, the first row. And then in your y plane, these will be the 3 components, and then in the z plane, you will have these 3 components. Okay. So now all these stress are at point P. Remember, all these stress are point P. So we are considering a point P, and we are constructing a very small parallelepiped, you can say, very small, which has negligible length. Okay, it is close to 0. We are just constructing at the point P. Just we are showing it as a big picture, but it is point P only. Okay, so this is called a stress. This is called your stress tensor. Stress tensor. You have read the vector, right? So vector means
Yes, sir.
stress
For
we
2D
generally know
we
it is
did
a
it.
vector, but this is wrong.
More
Stress is
circle.
not more circle.
No, sir. For 2D
What are you trying to say?
we did this for 2D planes, like one.
Yes, yes, yes. I'll come to that. I'm just giving you a brief idea of the stress. Okay. So at point P, we are trying to define the stress. So I am saying that it is not possible to define the stress at point P until and unless you know the plane. First point was that if you don't know the plane, you cannot say the stress. Okay. Next, I am saying that yes, it is possible. First, I said that it is not possible. Then I said yes, it is possible. But for that case, you need to know the state of stress at point P along 3 mutually perpendicular planes. Okay. So, and if you consider 3 mutually perpendicular plane, then the stress acting on each plane, we can from that we can construct a matrix. Okay. And with these 9 components, we can say the state of stress at point P. So this is called your stress tensor. So tensor means, vector means it has a magnitude and direction in general. Okay, this is also not the true definition, but in general, vector means your scalar means only magnitude, vector means magnitude plus direction, and tensor means magnitude plus direction plus plane. Okay, so it depends on your plane. So that's why it called a tensor. We just know these points. Later on, we will maybe have you learn in detail in your advanced courses. So you, for the time being, you know stress is not a vector, it is a tensor. And if we fix a plane, okay, if we fix a plane, suppose this is point P, and if we fix a plane, this is point P, and you fix a plane, any plane a dash, then you will have the form of your stress in terms of only your magnitude and direction. Then we can say that stress is a vector. If you fix a plane, then stress will come out to be a vector. Okay. So what I have shown in this 3D diagram, that here you have one normal stress component and 2 shear stress component, right? One is along your y and another is along your z direction. So if you consider now 2D, because mostly we will deal with 2D, so that's why you will have one normal component and another is your shear component. So in 2D cases, there will be one shear component. Okay. In 3D, you will have two shear component. In 2D, you will have one shear component. So if you fix a plane, then you can know the state of stress, and that we can say that this is a vector. Okay. So now uh, the probable you are saying that the stress will be your force per average area, but basically your definition of stress, if you try to see the definition of stress, the definition of stress is your the limiting value of the limiting value of the force when the area force per unit area when the area sinks to 0. Okay, suppose you have this point P, and this point P is the total normal stress or total force, not say, or I should say normal, so total force acting on this. Suppose you take a plane here. I think you have gone through this diagram. So this is point P. You just take a plane A dash, and this is your point P. And if you calculate the force, suppose this is your total force acting on the point P, and the area of point P is delta A, then you can define your stress as stress is your limiting value of the forces when the area sinks to 0. That means delta A tends to 0, del F by del A. The del F is the force acting on that point, and del A is the area of that point. When the area sinks to 0, that means it becomes the point size, then the force acting on that point, it is called stress. Okay. So in general, because this is the actual definition, but for our simplicity, for the simplicity of your calculation, we just write sigma is equal to F by A. Okay. Sorry, in average sense, we calculate the stress as average
in this
sense
case,
F by A.
Cross sectional area. F by A, the A denotes
Can you
the
repeat?
what area? So here A denotes the cross sectional area of the 3D object.
Yes, that is what I'm saying. In general, this is in senses. So I will calculate the force on this area, and I will take the area of this plane. This plane area is A. That will not be a point. Okay, this is a this surface area is denoted by A. The surface area of this plane is denoted by A, and the total force on this plane, total force acting on this plane is F. Okay, not point. You are not audible properly.
But if we can take multiple planes which is passing through P, but with this object, so different cross section area can be.
Yes,
we can get.
Yes. So you can, if this is the plane I have taken. First, I have taken a plane. True, you're true. Now, if you take a plane in different direction, suppose you are now taking a plane here. Okay, this is B dash. So then you need to calculate the force acting on this plane and area of this plane for average sensor. In average sensor, to calculate like this, right? Is it fine?
Yeah, at that average, we are taking that average is also acting on the point P. We are actually the limiting case.
Also, in that area, there is also point P. You can say there is also point. Obviously, the point P is there. So I see this is in average senses, and this is your true senses. This is the difference. But we ultimately will go for your average senses, because we want our life to be simple. Okay, we do not want complexity in life. So that's why in general we will calculate in average senses, or in general we calculate like this. But for your if the if the area is not that much simple, then you need to go for integration or higher mathematics, and you need to calculate from your original definition. Okay. So okay, we will proceed. So now, suppose you have at that point P, same point I am taking that point P, you have your you have taken two perpendicular plane. Okay. You have taken two perpendicular plane through point P. Suppose these are two perpendicular plane. Sorry. So two perpendicular plane you try to draw at point P. Suppose these are two perpendicular plane, and now I have taken the I am considering a two-dimensional problem, and this is your x-axis and this is your y-axis. Okay. So in this plane at point P, there will be your normal stress. This is sigma y, and this will be your shear stress. Suppose this is tau yx, and in this plane there will be your normal stress. Suppose this is sigma x, and you will have shear stress. Suppose this is your tau xy, right? So this is given now. Suppose at the point P, there are two perpendicular plane, and the state of stress on the perpendicular plane is given. Now you want to determine the state of stress at a plane which is at an angle alpha with the horizontal. So now what will be the normal stress at that plane, sigma alpha, and what will be your shear stress at that plane, that means tau alpha. So I think you are familiar with this problem, right? Sigma alpha, how to determine sigma alpha and tau alpha? I think you all know this problem, right? So if you know the state of stress in two perpendicular plane, two mutually perpendicular plane, you can determine the state of stress at any plane which is at an angle, so which is at some angle with horizontal or maybe vertical. So if you just try to calculate the load, and if you take the load on the horizontal direction, and if you consider the equilibrium of this body, and if you do these things, then you will get this type of equation, that your sigma alpha is equal to sigma x
sigma
plus
1 plus
sigma
sigma 2
y
by 2.
by 2.
Sigma x minus sigma y by 2 into cos 2 theta.
Yes, cos 2 theta plus tau xy sine 2 theta, right? And you will get your tau alpha. Tau alpha will be your sigma x minus sigma y by 2. This will be your sine 2 theta plus tau xy cos 2 theta. You just cross check whether this is means for this figure, whether this is true. I think it will be true, but it depending on your sign convention and angle of your this plane, there may be some differences in sign convention. There may be minus tau xy sine 2 theta, or this. So there may be slight change if you take the different sign convention. Here we are taking that compressive is positive, because we are dealing with soil, and in case of soil, mostly the stress is compressive in nature. Okay, so we are taking compressive stress is positive, and we'll consider the anti-clockwise, your anti-clockwise shear is positive. Okay, we'll consider your anti-clockwise shear as positive. That is, I think, same as your structural mechanics, but only difference is in structure generally tension is positive, but in soil we will consider compression is positive. So you will have this equation. Now suppose these plane are principal plane, right? The plane which you have taken, the mutual perpendicular plane, these plane are principal plane. So what is principal plane? There will be no shear stress, right? So only there will be normal stress. So now if you choose the principal plane and if you try to determine your sigma alpha and tau alpha, then you can just change this sigma x and sigma with sigma 1, and there is no shear stress. So you can determine this sigma alpha is equal to sigma 1 plus sigma 3 by 2, sorry, and plus sigma 1 minus sigma 3 by 2, your cos alpha. Sorry, I have written here theta, but it should be alpha because I have taken the inclination as alpha. Okay. Sigma 1 minus sigma 3 by 2 cos 2 alpha, and similarly tau alpha, you will have sigma 1 minus sigma 3 by 2 sin 2 alpha, right? You don't have any shear, so there will be no shear component. So now if we just observe these two equations, this is basically, if we try to write sigma alpha first equation as like this, sigma 1 minus sigma 3 by 2, sigma alpha minus sigma 1 plus sigma 3 by 2, and if we take square, and if we add the second equation, then you will have sigma 1 minus sigma 3 by 2 whole square, right? So from these two equations, we can get this equation, and this is nothing but a equation of your circle. So just observe that the center of this circle is will be sigma 1 plus sigma 3 by 2, 0, and radius will be your sigma 1 minus sigma 3 by 2, right? So with this equation, we have formed the equation of a circle which has a radius of this, and center sigma 1 plus sigma 3 by 2, 0, and radius is sigma 1 minus sigma 3 by 2. Okay, now if we try to plot this circle, so suppose this is your sigma axis and this is your tau axis, and this is your sigma 3 and this is your sigma 1, sigma 3 and sigma 1. So this will be your sigma 1 plus sigma 3 by 2. And if you try to plot this circle here, okay, suppose this is circle. Okay, so this distance will be your center, which is your sigma 1 plus sigma 3 by 2, and your radius, that means this radius will be your sigma 1 minus sigma 3 by 2, right? So this representation of the state of stress is called your Mohr circle, right? You are familiar with this, right? Section A and section B, both of
Yes, sir. More. Yes, sir.
circle, right? Okay.
Yes, sir.
So, so what Mohr circle basically? Mohr circle is basically your representation of state of stress in 2D. Okay? In 2D, we are representing the state of stress in 2 dimensions. So what is basically these coordinates? If you take any point on the Mohr circle, any point, this will represent the state of stress at a particular plane. Okay, so this is the representation of state of stress along the different plane on the point P. Okay. So we have taken that point P, and here we have considered earlier that these planes are principal plane, and we are telling that shear stress at 0, and we are calculating sigma alpha and tau alpha on a plane which is inclined at angle alpha with the horizontal. So now if you take the alpha any value, if you take any value of alpha, you can now find the state of stress corresponding to that particular inclination or corresponding to that particular plane in the from this Mohr circle. Okay. So this is also you have already learned, but I will have one example. I will give you an example, and we will end today's class. Okay. So suppose you have a state of stress which is given. Suppose this is a soil sample, and the stress acting on this soil sample is 52 kPa, only normal stress, and along this plane, along this vertical plane, this is acting 12 kPa. Right? So now you need to determine the state of stress of along this plane. What will be the state of stress along this plane, where your alpha, that means inclination with horizontal, is 35 degree. Okay. So for the determination of state of stress at any plane, we will follow the pole method. Pole, or this is also called origin of plane. Origin of plane. So we will follow this method of pole or origin of plane. Okay. So this is a graphical method to calculate the state of stress at any plane. So you take any standard graph and you try to plot or try to draw the Mohr circle corresponding to this state of stress. That means the sigma 1 here is equal to 52, and your sigma 3 is equal to 12, sigma 3. So you plot your Mohr circle corresponding to this state of stress, This is your sigma 1, which is 52, and this is your sigma 3, which is 12, and the radius, you know, this will be your, just in order to draw the circle, you need to know your center. That means XC and RC, YC. XC will be here 52 plus 12 by 2, and YC will be 0, and your R will be 52 minus 12 by 2. Okay, this is 2. So with this center and radius, you construct this circle or plot this circle. So this is now your Mohr circle. So what is the pole for this Mohr circle? So for identifying your pole, you need to see that which stress is acting on which plane. Okay. So if you try to see your sigma 1, which is 52, this is acting on a horizontal plane, right? So you identify your sigma 1, this is your sigma 1, and you try to draw a horizontal plane from the 52. If you draw a horizontal plane, it will cut the point sigma 3. Okay. So this is your pole P. We denote it by P. So what is your pole? If you know the state of stress along any plane, you identify that point and you draw a parallel line, a line parallel to that plane in the Mohr circle. Okay, from that point. Okay, so here 52, we know it is acting on a horizontal plane. So take this point 52 and draw a horizontal line. It will cut the Mohr circle at point P. So this will be your pole. Similarly, if you try to draw through this point, that means for this plane, that means which is vertical. So in the vertical plane, you have 12 kPa. So this is your 12 kPa, and if you try to draw a vertical, it will cut the same point. Okay. So that is that will cut the same point. So that this is your pole or origin of plane. Okay. So now you want to know the state of stress along this plane. So you just draw this a plane parallel to this plane. Okay. So that means if you draw a plane which is 35 degree with the horizontal, that will cut the Mohr circle at some point, and this will be your state of stress. Suppose this is point A, and it will give you the state of stress at that plane. Okay, you try to measure here from this from your graph what is the value of sigma and what is the value of, this is the value of sigma and this is the value of tau. So in this way you can determine the state of stress along any plane. You take this plane, so you draw a parallel plane from the pole like this, and this will be your A point. Now that means this plane, if this is your B dash plane, so suppose this point is your B plane, B point. That means this point will denote the state of stress along this plane. Okay. So this pole method is uh, known to everyone. Is it clear to everyone what is pole and how do you calculate the state of stress through pole method? If it is clear to you, means if already you know, then I will not discuss it further. But if you don't know, then I will discuss 2 or 3 more problems in the next class, because time is now 11. Yes, Tomajit. Tomajit,
স্যার বলছি যে আমরা করেছিলাম যে মোর সার্কেলে যদি একটা প্লেন টু থিটা অ্যাঙ্গেলে থাকে তাহলে সেটা রিয়েলিটিতে থিটা অ্যাঙ্গেলে টিল্ট করে থাকে এক্স প্লেনের সাথে। তো এখানে স্যার সেটা
yes, that may be your Tomajit. You should, when you will read something, you should read it carefully. Okay. if you join this line, this point and this point, so this will be your 2 theta. Okay. So the 2 theta with respect to what, that you
স্যার
should,
আচ্ছা সেন্টার থেকে জয়েন করতে হবে।
so 2 theta with respect to what, that you should know. Okay.
সেন্টার থেকে
So if you all know about this method, then I will not discuss it.
স্যার একটা কোশ্চেন আছে স্যার।
Please ask.
স্যার এখানে স্যার শেয়ার স্ট্রেসটা কনসিডার করা হচ্ছে না কোন, only direct stress?
Okay, shear stress, I did not consider here shear stress for the simplicity. Again, you always can take the shear stress and how to draw the Mohr circle by considering the shear stress. That is also there was an example. I was supposed to give you that example also. There is nothing that I will not consider this. I can consider and I can plot the Mohr circle and I can determine the state of stress at any plane. Okay, that is also possible. That is, I just, for the simplicity, I have taken here only your principal stress, that means shear stress of 0. And in case of your soil mechanics for this shear strength chapter, basically we will do your triaxial test and you will read it later. So in that triaxial test, we generally apply the normal stress only. Okay, that's why I have started with this. Basically, you will need this kind of problem for this chapter, but we can always construct the Mohr circle for where shear stress is also acting. That example also, I was supposed to give that example also, but it is now 11. So I think if you want, I will discuss maybe 2 or 3 more problems in this pole method of pole, or otherwise, if you know everything, then I will not repeat this. What do you say? Section A, section B. Should I give more example on this, or it is clear to all of you? See, there is nothing to be shy or something. If you don't know, if maybe there may be 60 people on section and maybe 59 knows and one he does not know, then in that case also I can discuss for him only. Okay. So this thing we discuss.
Yes, sir.
So I'll in the next class, then I'll give you more examples. Okay.
Yes, sir.
So that
স্যার নেক্সট ক্লাসে এক দুটো
So,
এক্সাম্পল দিলে একটু ভালো হয়, বা একটা দুটো অঙ্ক করলেও বোঝা যাবে ব্যাপারটা,
yes,
কনসেপ্টটা
in the next class I'll give you, yes. And I don't know whether the next class will be physical or online. I hope the class will resume offline soon, because there are many disturbances in online classes. So
Sir,
hopefully
do you
we
know,
will
are we
have your
supposed to,
physical class from the next week.
Sir, are we supposed to visit the college
Yes,
tomorrow?
yes, please.
No, like physical classes will start from tomorrow.
না
Uh,
না না,
you can
নোটিশটা
visit
দেখ না,
because,
অফিসিয়ালে দেওয়া আছে।
see, there is no restriction to visit the campus. Only restriction is there will be no physical class for the time being. Okay, now they will you announce the classes when the offline class start. The university will announce, or have already announced, I don't know. So okay, everyone, this is the end of your class for today. Next class we will discuss this
Thank you,
whole
sir.
method, or 2 or 3 more. I'll give 2 or 3 more examples, then we will go further. Okay. Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
You've taken the screenshot, you can send it to me through the WhatsApp. Okay,
Thank you, sir.
thank you.
Yes, sir. I'm sending it to you.
Okay.